You've probably seen one of these before, but you've never paid it much attention. You think you know what it is? Look closely. These slender shapes that sink into the earth, this pulsating chrysalis, this moth, expertly designed for flight. It's one and the same insect, the pine processionary caterpillar, a fearsome conqueror. For thousands of years, the pine processionary caterpillar, an indigenous European insect, has been marching slowly but surely towards the north. At the onset of spring, the insect colonies form a procession and leave their nests never to return. The pine is their natural habitat. They feed off its needles and are a threat to the entire plot of land. The processionary caterpillar is the great destroyer of Europe's forests. In the Landes region of France, processionary damages are so spectacular that you can actually follow the animal's trace. These trees have not been burned. They have been entirely devoured by packs of starving caterpillars. In less than 100 years, the processionary has crossed the whole of France as far as Brittany and the Paris region. The authorities now understand the threat they are facing. Several research teams are studying the behavior of this disturbing insect in the hopes of curbing its expansion. In southern Spain, geneticist Carol Kerdelhue and ecologist José Hodard believe that the expansion of this destructive caterpillar began in the area.
We're trying to determine where the pine processionary was able to survive the various frosts that have taken place during the Quaternary. Most European species, in this case, survived in the zones that remain temperate. The problem is that there are no processionary fossils, unlike many other organisms that leave a trace, such as shellfish, trees, or vertebrae. So we have to use an indirect genetic approach to try to understand what happened.
Genetic analysis reveals that during the last ice age 20,000 years ago, the pine processionary caterpillar was able to survive in 4 refuge zones. It is from these zones spared by the ice that the processionary set out to conquer Europe. The temperate oceanic climate and the warm winters of these regions were propitious for the caterpillars. These ones have just hatched, but they already have one obsession: eating. The pine processionary can only live in colonies of 100 to 150 individuals. Instinctively, it forms a procession in order to feed. For many years, scientists have wondered how such a tiny insect was able to cross over the Sierra Nevada range at an altitude of over 6,500 feet.
It was initially believed that the main European mountain ranges would block the pine processionary's migration from the southern refuges to the colonized zones in the north.
So Carol, we are now about 1,000 meters in altitude, and as you can see, you can appreciate that vegetation is changing.
And do you know until which elevation we will find pines and pine processionary moth?
Pines around 2,200 meters in altitude, but we have different species of pine along the gradient. We have in the lower part Pinus alepensis, the Aleppo pine. Then here we have Pinaster, Meridian pine, and then in the top of the mountain we have Pinus nigra and Pinus sylvestris.
The fate of the processionary caterpillar is therefore closely linked to that of the pine tree. Its favored variety is the black pine, but if none are to be found, the processionary is an opportunist and will make do with other pine varieties. Its impressive claws allow it to grab all kinds of needles, thick or thin, hard or soft, smooth or rough. Its ability to adapt its diet has been a decisive advantage. Switching from one pine to another has helped it to cross over the Sierra Nevada.
Mountains are the ideal environment for the pine processionary. When there are climatic changes, the processionary adapts its altitude in order to find its favored ecosystem.
The mountains may be advantageous to this caterpillar, but higher altitudes equals lower temperatures. However, the processionary doesn't mind. This is one of the few insects that can easily survive the 3 months of winter. Its winter nest protects it from bad weather. This unique ball of silk has helped the processionary march upwards and along the mountain peaks, reaching altitudes that would seem unreachable.
This is one of the places, the highest places at which we can find this animal in Sierra Nevada.
And you think it's a recent expansion?
Yeah, some years ago it was not here for sure. So it's a recent expansion.
The nest thickens and evolves as the individuals grow bigger. Each caterpillar unrolls a silk thread as it moves. The regular toing and froing during the 3 winter months produces a constantly growing nest. The nest is made up of 2 superimposed layers. The inner layer is thick and serves to isolate. The outer layer is more flexible and serves as the framework. There is no entry or exit opening. To re-enter their impenetrable fortress, the caterpillars must push their way through the weave. The colder the region, the more solid the framework. The thicker the inner layer, the more the caterpillars are protected from the cold of winter and from predators. The nest acts as a solar receptor, absorbing nearby infrared radiation. Jérôme Rousselet is a biologist at the National Institute of Agronomic Research in France. He studies the thermal characteristics of the nests in order to identify at what temperatures the caterpillars will die.
This nest is generally well exposed to the south so as to take maximum advantage of the sunlight. With this heat camera, you can see that the nest temperature is close to my body temperature. This is considerably higher than the outside temperature, which today happens to be in the vicinity of 54 degrees. The caterpillars can withstand the cold from the 3rd larval stage onwards, but thanks to this nest, during the course of the winter, they'll be able to resist temperatures as low as 3 degrees. Below this limit, they die. They'll also die if a lasting cold spell stops them from leaving the nest at night to feed.
When they arrived in the northern Iberian Peninsula, the pine processionaries stumbled upon the Pyrenees Mountains, whose highest peaks rise to an altitude of 11,100 feet. This would seem to be an insurmountable obstacle, yet they crossed over. Thanks to the Atlantic coastline's warm winters, a trail of caterpillars bypassed the mountains by following the coast. On the other side of the range, they discovered a highway to the north. Man had inadvertently rolled out the red carpet, the greatest artificial pine forest in Europe, and it's a 3-star restaurant for the processionary caterpillar. They invaded this new territory, which became the base for their conquest of France. Hervé Jactel, a researcher at the INRA, studies the impact of processionary caterpillars on forests.
On these leaves, you can see how the processionary pine eats away at the foliage. When the eggs hatch, the young in the larval stages prefer to eat old leaves, 2- or 3-year-old needles. The next larval stages are not as picky, or perhaps more voracious. They feed on the needles of the current year that contains more resin. When all the foliage is consumed in this fashion, the levels of defoliation can reach as high as 100%. This is what we can see in the trees in this colony, which is undoubtedly one of the most infested ones in all of the land and perhaps in all of France.
The caterpillars wait for nightfall to leave the nest. They are vulnerable during daylight, but at night they are protected from many predators. They're not affected by the darkness because they're practically blind anyway. Their eyes are in fact 4 microscopic ocelli, an atrophied arc-shaped organ. Their sense of smell, however, is highly developed. This is what guides them to the tastiest needles. Many animal species fast during the winter. The processionary caterpillars, on the other hand, gorge themselves with food every night. Four or 5 nests are all it takes to strip an adult pine tree from top to bottom in the space of 1 month.
They diminish the tree's photosynthetic capacity, so it can no longer allocate as much energy towards growth. A drop in tree growth usually goes along with the defoliation caused by the processionary, and in rare cases it can cause tree death. Defoliation may lead to death in 2 situations. The first is when the weakened tree is attacked by secondary insects, such as the bark beetle. The second is when the tree is defoliated over 2 or 3 consecutive years. The tree is so weak that it dies in the end.
The pine processionary has exerted ecological pressure on this forest for hundreds of years. You'd think that the species would be content to prosper in this huge Garden of Eden. But at the beginning of the 20th century, they suddenly began to march towards the north. Scientists would like to know where their forward march will end so that the contaminated zones may be marked out. Mathematician Christelle Robinet has put aside her algorithms and her computer data in order to lend a hand to Jérôme Rousselet and his team. They've been alerted to the presence of processionary nests just north of Orléans. This region, until now, showed no signs of infestation.
We've just entered a zone that wasn't colonized last year, so we're definitely at the colonization front, meaning a zone where the population is small and a few pioneering individuals have settled, not without difficulty. Our goal will be to tag the exact location of this last nest. If we find it, we will explore another area a few miles from here, in the hope of finding a totally processionary-free zone. This is how we succeed in establishing the border between the colonized and the non-colonized zones. Then it'll be your turn to play around with some models.
The front line is a tricky area for the pine processionary. There are few nests now, but if the conditions turn out to be favorable, new colonies will propagate.
I think there's one here.
Yes, there's one.
Let's check it out.
A small one in the back, about mid-height.
Okay, I see it. Okay, we've got that one.
I'll beep it. Perfect. Now we need to see if there are any others nearby.
Back at the laboratory, Christelle is transferring the GPS data recorded in the field.
Here's the GPS location of the nest that we saw in the forest yesterday. Let's assume that the pine processionary has settled in this 5 by 5 mile square. Thanks to observations conducted all winter long, we'll be able to establish the limit of the northern colonization front. If we increase the scale, we see that the colonization front has been charted all the way from Brittany to Switzerland.
This recent expansion, which is progressing quickly and unexpectedly, intrigues scientists. They are studying the adult processionary caterpillar and the different stages of colonization in the hopes of understanding what is taking place. The caterpillars have sunk into the ground. They have spent several weeks in this position and have secretly turned into moths. This is the imago, or the adult form of the pine processionary caterpillar. This moth only lives for one day, so all its energy must be devoted to fulfilling its destiny to reproduce. The processionary colonizes new lands by air, so the scientists are focusing on evaluating the species' flight capacity. They hope to deduce the amplitude and the speed of the spread.
It's impossible to follow processionary moths in the wild and to get a feel for the way they spread out. We need to know more about the flight capacity of the males and, more importantly, the females. They decide where future populations will settle. We've constructed an experimental device that enables us to measure flight distances. This device is simply a rotating axis that we place an insect on. We can measure the amount of circles it makes, and then we convert that number into distance.
Most of the time, the female is the first to tire. Her egg-filled abdomen weighs her down and limits her flight capacity. The male is more streamlined. The strong muscles in his highly developed thorax make him a powerful long-distance flyer.
The gender ratio is relatively balanced. There are as many males as there are females. However, they don't roam at the same time. During the day, the males roam earlier. This means that when the males set out, there are few available females. Their flight capacity, an average of 6 to 9 miles, is great enough to allow them to search the entire zone for the rare female. Through this behavior, they disperse and ensure a genetic mix on a local scale.
The male takes off on his first and final night flight. 1 to 2 hours later, it's time for the females to roam. They deploy their reproductive organs and release a sexual pheromone. The male in flight detects this chemical molecule thanks to its ultra-sensitive antennas. Only the hardiest contender receives the female's favors. He throws his remaining energy into the sexual act, which lasts over an hour. He then dies of exhaustion, after having left his precious genetic legacy to the next generation. The female now chooses a pine needle suitable for laying her eggs. She will lay over 200 eggs, and she will cover them with scales from her belly. A few hours later, the female dies too. She leaves behind a mound of eggs that look convincingly like a pine bud.
The female's flight capacity is much lower than the male's, but she can still fly an average of 1 mile. The female decides where she lays her eggs, and this determines the location of the next generation. So the female's lesser flight capacity limits the speed of expansion north, but the survival of the population she has produced will depend on the weather conditions.
Because the caterpillars develop primarily during the winter season, they're highly sensitive to even subtle temperature variations that represent one of the key factors in the progress of this destructive animal. Christelle Robinet is compiling temperature, flight speed, and pine density to establish a statistical model to predict the spread of the caterpillar.
2 factors influence the processionary's progress. The first is global warming, and since the early 90s we've observed a rise in the minimum winter temperatures in France. This has helped the processionary to survive the winter and to settle in areas that have become more welcoming in terms of climate. The second factor is the presence of pines. On this map, you can see all of the forest zones in France. In certain regions, like the Beauce, there aren't any forests. You would think that this would hinder the caterpillar's progress. If you look along the A10 highway, you'll see that there are plenty of pine trees placed at intervals of up to 1.5 miles. The processionary can move from pine to pine and advance even faster than if it were crossing a forest.
The processionary moth's exceptional flight capacity enabled it to travel beyond forest zones. But man paved the way. We've planted pine trees, providing the processionary with a supply base. We've also warmed its environment with our emissions of greenhouse gas that have made winter temperatures rise. The processionary now lives among us. Hiding in its nest, it is preparing for a one-way trip. On a sunny spring day, they set off on their ultimate procession. The silk thread woven by each caterpillar in its wake is what links them together. They move forward head to tail. Each head touches the belly hairs of the animal in front of it. Once the colony is on its way, there's no stopping it. A female is always at the head of the procession. The colony can wander like this for several days. The processionary is at its most dangerous during this phase, when the forward march is in open terrain. If it senses a threat, it releases hairs that are coated in a highly irritating substance. These lightweight hairs float in the air and contaminate the zones around the nests. This venom can be harmful to both animals and men.
People are often surprised to see a show up so heavily protected. In fact, city dwellers are usually unaware of the risks associated with these big white balls that are found in trees or the trail of caterpillars moving in between their feet. We're this well protected because the hairs are highly allergenic and can provoke reactions that at best may resemble poison ivy and at worst could induce anaphylactic shock.
A serious allergic reaction triggered by the microscopic caterpillar hairs. When the caterpillar feels threatened, it rolls into a ball and opens little pouches located on its back containing the stinging hairs. As a defense mechanism, the caterpillar shoots off these tiny hairs that act like invisible harpoons. When they reach their target, the hairs break and release their venom. Their sharp, barbed points can only be seen through an electronic microscope because they measure no more than 200,000ths of a millimeter. These hairs, dispersed in the wild, will remain poisonous for over 50 years. Huge quantities of these hairs get caught in the silk threads of the nest, turning them into time bombs.
The nest will remain poisonous for several months after the caterpillars have left. Throughout their growth during the winter months, they shed their larval skins several times. Each discarded skin contains millions of these hairs, which accumulate in the nest.
The spread of the processionary caterpillar is creating a considerable sanitary and ecological impact. It was urgent for both government and the scientific community to declare war on this destructive insect. The pine processionary is a polymorphous insect. It goes from caterpillar to chrysalis to to moth. There are 3 enemies, not just one. While the processionary is still a caterpillar, the solution is to destroy its nest. This is a massive field job, and small towns often feel powerless when faced with such a task. And it's not a foolproof strategy. The moment has to be well chosen. Caterpillars are unpredictable fighters. They're capable of abandoning their nests earlier than expected. Fighting such a clever adversary requires a certain amount of cunning. As soon as the enemy leaves its silk fortress, it marches in neat columns. Annie ARTE is a biologist at the National Institute for Agronomic Research. She's developing a way of eliminating entire caterpillar colonies using the tracking pheromones the caterpillars release as they move.
For the caterpillar, these tracking pheromones are a matter of life or death. From the earliest stages of its development, it must scatter in order to feed itself. The tracking pheromones allow it to find its way back to the nest that protects it from the cold. I have spread tracking pheromones on these strips of paper. Now I'll put the caterpillars on these strips. You can see that they're following the scent. They move their heads around from time to time, searching for their trace.
The caterpillars follow a path of chemical traces left behind by fellow processionaries. According to the scientists, it should therefore be possible to influence the caterpillar's migration and lead them to a dead end.
Our study involving the tracking pheromones strives to define these substances. We're looking to find out what makes up the pheromones so that we can artificially produce a synthetic variety. If such a synthetic pheromone were applied to a tree, it might provoke a dispersal of the caterpillars. If dispersed on the wrong tracks, they wouldn't be able to find their way back to their nest. Because they need to live in groups, they couldn't survive the winter temperatures on their own.
For the time being, this artificial pheromone is proving very difficult to synthesize. It will most likely take several more years of research in order to move from experimentation to implementation. There is another possible strategy on the battlefield, using the enemy's own weapons against him. For example, the processionary caterpillar, who can only move forward in a straight line, is kept going around in circles thanks to a simple plastic tray. Instinctively, they need to sink it to the ground. A bag of soil will fool them and trap the entire colony. There's nothing left to do but collect the bag. Unfortunately, it's hard to imagine equipping all the pine trees of a given community. Those who escape the trap continue their procession, guided by their innate desire to sink into the ground. When the column leader finds a suitable patch of land, a sunny one, all the caterpillars regroup. Working together, they push themselves into the ground to a depth of 1 to 8 inches below the surface. Each caterpillar wraps itself into a nymph cocoon. Once it's all wrapped up in silk, an astonishing transformation takes place. caterpillar will become a chrysalis. The intermediary stage between a caterpillar and a butterfly or moth. Once the transformation is complete, depending on climatic conditions, the chrysalis may enter a state of diapause. It puts a complete stop to its development, inert and camouflaged to blend with the earth it's hiding in. It's practically invisible to the human eye. But it's still not safe. Sharp, skilled beaks are close by.
What's interesting here is that we have all the right ingredients for the ideal hoopoe territory. There's the pine forest, which will provide foods because the processionaries spend all winter there. They will sink into the grassy zone at the end of the winter, and it will become a feeding ground for the hoopoe, raising its offspring.
The hoopoe is a protected migrating species that is relatively common in our woods. It spends its winters in Africa and returns to Europe for the nice weather, which is bad news for the processionary.
It's pulling a victim out of the ground there.
It's digging up a processionary chrysalis. You see, it's removing the cocoon. This is a key predator because it feeds its young on processionary pine chrysalises in the springtime.
I see.
This species specializes in buried prey. It unearths them with its beak. An Italian colleague, Andrea Battisti, discovered that up to 70% of chrysalises could be eaten in this manner.
After a few weeks underground, the chrysalids that have been lucky enough to escape the hoopoe resume their metabolic activity. The processionary reaches the final phase of its metamorphosis. It becomes a moth. After the mating session, the female begins her search for the ideal pine in which to lay her eggs. This ravager, after having spent so much time on the ground, is finally airbound. She is searching for a pine tree well exposed to sunlight. Choosing the right tree is critical for the survival of the next generation. The female moth has a preference for the forest's edge, the treetops, and the isolated pines that stand out on the landscape. The scale of the war against the processionary has changed. How do we defend an entire forest against an invasion of female moths? Quite simply, by making it invisible to the eye of the moth.
First of all, we discovered that installing a border of leafy trees in front of the pines seemed to limit the attacks. This is probably because to the processionary, the outline of pine trees is a signal to lay its eggs. We pushed this idea further and studied the smells produced by the deciduous trees. We found out that these smells are repulsive to the adult pine processionary, so this also limits attacks. Right now, in this experimental forest, we're comparing 31 different mixes that associate pines and deciduous trees, oaks and birches. We're working to optimize the mix and obtain maximum protection against the pine processionary while maintaining sufficient maritime pine production. We're also working on extracting the olfactory ingredient found in the essence of birch. We're trying to develop a diffuser so that we can protect the pine trees planted in parks and gardens.
Deciduous trees have another distinct advantage. They are home to many of the processionary's natural enemies, such as the epipigger, a grasshopper that loves insect eggs. If this grasshopper is lucky enough to come across a stash of processionary eggs, it will eat every last one of them. The leafy trees also house another fearsome yet graceful predator, the great tit. In the winter, when food is rare, some birds are willing to take the risk and approach the caterpillars despite their venomous hairs. The tits have learned how to pierce the nests. They carefully catch the caterpillars by the head, avoiding any contact with the poisonous hairs. But will these predators be found in all the lands conquered by the Processionary? Will the weapons conceived by man succeed in curbing this progression towards the north? The only trend suggested by the different models is that the Processionary will continue to spread. And that's not all. An unusual phenomenon involving the Processionary has caught the attention of Portuguese scientists, particularly in tracts of forests located to the north of Lisbon. In 1997, an unusual proliferation of processionaries took place in the middle of summer. Entomologist Rosa Maria Paiva was the first person on the scene. 15 years later, she's returning with Manuela Branco, a biologist at Lisbon's Superior Institute of Agronomics. Manuela wonders if the disturbing propagation in the summer of '97 may have been the doing of a mutant processionary caterpillar, evolving into a new species.
So this is here the place that you saw this huge infestation, strange infestation of the pine processionary moth in 1997, is it?
Yes, in fact, we are very near the place where it started. In Lisbon, I read in a local newspaper from this area that something odd was happening here, that a high infestation of processionary moths was ongoing. As you know, the larvae of processionary moths develop through the winter and not in the summer. I came here immediately on the 2nd of September, and what I've seen, it was something unique. The larvae had covered the trunks of all the pine trees. So it was the most extraordinary sight that I've ever had in my long life of entomology.
The mutant caterpillars have shifted their life cycle. Instead of developing during the cold months, like the processionaries that build winter nests, these caterpillars develop during the summer. This seasonal shift is no insignificant detail. It produces decisive behavioral changes. In particular, it affects their nest building. By developing during the course of the warmer season, this new version of the processionary doesn't need to fight the cold, so its nest is no more than a few silk threads.
Here we can see very well, very clear, the differences between the larvae of the two populations on this time of the year. So this larva is from the summer population, the mutant one, and she's very advanced. She's on the 15th star, she's ready to pupate. And this one, the little one, she's 1st star larva, she has just born. She's the normal winter population, and this is the normal phenology. And the interesting thing is that you can find both on the same places, and even in some cases on the same trees. So since they live together, they are sympatric, but they are isolated by time. So it's a kind of allochronic speciation, very rare in nature and rarely observed.
Although the mutants appear identical to the processionaries living on a winter cycle, they have most definitely developed specific adaptations that enable them to live on a summer cycle.
And during summertime, particularly on this area, the temperatures can be very high. There are some days where the temperatures are above 40 degrees. So this was one of our questions. How can they survive these very harsh summer times? Because we know from previous research that the limit of survival will be about 32 degrees. So we thought, how can they survive if our temperatures are much higher than that?
To find out more about this disturbing question, Manuela and her team will compare the heat resistance thresholds of the standard and mutant caterpillars. Tens of specimens are being prepared for a stay in a closed chamber that simulates increasingly hot daily cycles.
In the lab, we compared both populations, winter and summer population. And our main conclusion was that they really differ on these limits of thresholds. I mean, the summer population can survive at higher temperatures than the winter population. And the difference is 6 degrees Celsius. So the summer population can have a tolerance threshold 6 degrees Celsius above the winter population, which is really a lot and means that there is an adaptation to survive on these conditions during summertime. With time, in a very, very long time scale, it could give rise to a new species, if there was time for that.
The presence of these two caterpillar populations, able to attack the same pines one after the other in the same year, is a considerable threat to Portuguese forests.
We could observe 2 defoliations of the pine trees, one during summer and the other during winter, and this can be very stressful for the trees. Also, the summer defoliation is worst because the trees cannot recover no longer. After the winter defoliation comes spring, and during spring, trees reproduce new needles, so it's more easy for the trees to recover from the winter pine processionary moth.
For the moment, the mutant caterpillar population remains confined to a zone of about 50 square miles. But for how long?
And also, what will be the future of this population? Where it is going to expand? What were the genes that mutated, for instance? Can it happen in other populations? There is still many scientific questions we have.
Scientists continue to worry about the spread of this mutant population. But an additional, more direct threat worries them just as much.
The pine processionary is spreading in a natural manner, but it can also do long-distance hauls. We've discovered isolated settlements around Paris, in Picardy, and in Strasbourg, all far from its original zone.
The processionary has a secret weapon that helps it to conquer new territories. Extended diapause. Under certain conditions, chrysalides can prolong their dormancy for several years. This extraordinary adaptation mechanism explains the reappearance of the caterpillar in regions where it was considered to be eradicated. So, we're never really sure we've got rid of it. And finally, an accidental transfer is always a possibility. Chrysalides sleeping in lumps of soil have inevitably been transported through Europe. Greater travel is not out of the question.
In Europe, the pine processionary is a native species, spreading as a result of climatic change. But in other parts of the world, there are several highly suited regions for it to settle in. If it were accidentally transported to these places, the processionary will be declared an invasive species.
The processionary caterpillar's exceptional fertility rate and its remarkable ability to adapt, combined with global warming and globalization, place the planet within the grasp of a conqueror that, to this day, remains undefeated.